Hi, I'm Suresh Kumar, working as assistant professor in Kongunadu College of Engineering and Technology in Department of ECE. So today we are going to discuss about the subject is microwave engineering and optical communications. So here the unit number one is microwave tubes and solid state devices. So in generally the microwave frequencies which is generated by two different devices. The one is microwave tubes and another one is solid state devices. So microwave tubes means it should be used to generate the microwave frequency in very high ranges. So whereas in the low frequency ranges, we are using the solid state devices. So generally the microwave tubes, which is classified into the two type, the one is called as a O type tube and another one is called as a M type tube. Here the O type tube means the electric field and the magnetic field both are linear. This cases which is called as a O type tube, and next one cases is M type microwave tube. Here the M type tube means electric field and magnetic field both are the perpendicular to the each other. So in O-type tube, the electron movement in the form of linear shape. But in the M-type tube, so electric field and magnetic field are both are perpendicular. So that in M-type tube, the electron movement which is in the form of circular. So this is the general classification of the O-type microwave tubes. So based on the cavity, we are classifying into the reflex klystron and then a two cavity klystron, and then based on the slow wave structure, we are classified into the helix traveling wave tube and then a backward amplifier, and the final one is a backward oscillator. So these are all the some basic classifications in the microwave tubes in O type. So the most important is what is klystron. The klystron is a vacuum tube that can be used to either as a generator or as an amplifier. Okay, so this klystron will be used on the two purpose. The one is called as a generator and another one is called as a amplifier. So here the basic configuration of the two type of klystrons are available. The one is called as a reflex klystron and another one is a two cavity or multi cavity klystron. Here the reflex klystron is the microwave oscillator and the two cavity klystron is a microwave amplifier. So here what it is called as a two cavity klystron. Okay. So now we have to see that the basic working principle of the two cavity klystron amplifier, how it will be amplify the low frequency microwave signals. Okay. So before that we must know what is the basic principle of the two cavity klystron. The basic principle of the two cavity klystron is a velocity modulation. This is the most important. The velocity modulation is the basic principle of the two cavity klystrons. And then what is a drift space? The space between the buncher and the catcher cavities, which is called as a drift space. So now we will see the block diagram of the two cavity klystrons. So here we are having the two number of cavities. The first cavity, which is called as a buncher cavity, and the second cavity, which is called as a catcher cavity. So here we are having the giving the input at the buncher cavity and we are getting the output from the catcher cavity. So in the input side, we are giving the very low frequency input, and in the output side, we are getting the high frequency output. So here we are having the cathode. The cathode will emit the electron. At the end of the side, we are having the collector. Okay. So when we are applying the proper biasing voltage to the cathode will emit the electron. The emitted electrons is traveling via the buncher cavities. Okay. So when these electrons are traveling via the buncher cavities, at the same time we are giving the RF input at the buncher cavities. So when the both RF input and the electron is meet at one point, so in drift space, both the RF input and the electrons are meet at this point. So when the RF input is positive off cycle, so in the time, due to the velocity modulation process, the velocity of the electron speed will be increased. So when the RF input in the negative off cycle, the velocity of the electron input will be less. And when the RF input at the zeros position at 0 time period, there is a no changes in the electron velocities. So due to these actions, the electron bunches will be created in the drift space. Okay, so due to this actions, that means when the positive half cycle, the velocity will be increased. When the negative half cycle, the velocity will be decreased. When it is a zero biasing, there is a no change in the velocity. Due to these actions, the electron bunches will be created. These electron bunches will be getting as a amplified output at the catcher cavity. This is a basic principle of the two cavity klystron amplifier. Thank you.